Hello guys, welcome back to my channel Memo African Motives, still working on mathematics and form. So actually in this platform we shall have a continuation which is still working on the question paper which was written in February 2022. So we just want to see how we were supposed to answer this typical question on question number 5, which had a total of 20 marks, as you can see guys. So let us quickly rush through and see what we are given and how are we supposed to answer this part. So on question 5 there we are asked to solve the value of x and y using determinants. So okay, which means here this is an indication of what determinant of this matrix is equal to 0. Also the determinant of this one is equal to 0. So what can we do actually to find the values of x and y? All right, this is what we know, that whenever I am calculating determinants, I'm going to start with the first one. That's xy 1, 1 minus 1, 1, 13, 2, and 1. So if you manage to watch some of the classes that we had, I talked about a condition whenever you're calculating the determinant that you're going to apply this concept. You affect each row by its corresponding sign, which is you start with plus, minus, plus, minus, plus, minus, plus, minus, plus. That's how you can easily take the sign that is going to affect each row or any corresponding column that you be given. So in this case, I'm going to choose this row. I'm going to work with the first row, this one. All right. So that means the signs are going to affect like this from this row, since we have got plus, minus, and a plus like this. So that's how these signs are going to be affected. So what does this mean? You remember that you are going to multiply, this is plus times x, which is x. Then you find the determinant of the matrix that is going to correspond when you close the column and the row where there is x like this. So as you can see, we are left with minus 1, 1, 2, and 1, this part here. So that is the one that you're going to write, minus 1, 1, 2, and 1, this part that we had. So you close the row like this, and you close also the column. All right. We move on to minus. So this is minus and y, so it's going to be minus y like this. You do the same. You close the row where there is y, which is this row, and the column, this is the column, so which means you're going to be left with 1, 1, 13, and 1. So you're going to be left with 1, 1, 13, and 1. Plus, this is plus 1, so it's plus 1 like this. You do the same. Close the row where there is 1 and the column where there is 1, which is this column. So as you can see, we are left with 1, minus 1, 13, and 2. So that's 1, minus 1, 13, and 2 like that, which is equal to the determinant that we are given, which is a 0 like that. So it's like you have created an equation there where you have to solve for x and y there. All right. Remember, determinant is the product of the major diagonal minus the product of this. So it's going to be like negative 1 times 1 minus 2 times 1 like this. Then you multiply by x. So this is going to give us negative 3. So here we're going to obtain negative 3 times x, which is negative 3x. You do the same here. The product of the major diagonal, this is your major diagonal, this one, minus the minor diagonal, which is this one. So it's 1 times 1, which is 1, minus 1 times 13, which is 18. So 1 minus 18, that is minus 12, times minus y. Take note, there's a minus there. So minus 12 minus and minus, that's a positive there. So it's going to be plus 12y. All right, we do the same here. We calculate the determinant again for these two. That's 1 and 2 there, which is going to give us 1 times 2, that's 2, minus 1 times 13, which is minus 13 like this. So that's a plus, which is 2 plus 13, which is 15, times 1, that's going to give us a 15. So we are going to obtain 15 in this case, which is equal to 0 like that. So as we can see, we have actually formulated an equation there if you are to cross-check properly. So I can choose to reduce this equation if I want. I can actually choose to reduce this equation. Let's say I want to make x the subject. Depends with how you want to write your equation. Okay, so I'm just gonna divide by -3 by -3 so that this can be a positive. So this here is going to give us positive x. 12 and -3, that is -4y like this. 15 and -3, that is -5, is equal to 0. So that means I can make x to be the subject here, which will be transpose to this side, that's 4y, transpose this to this side, that's plus 5. Or you can just leave it like this. So I don't know how you're going to write it or to have it, but you can make your x to be the subject, or you can even leave it like this. All right, so as we can see that from the first determinant we have formed an equation, but this equation has got x and y, so which means we can't solve for anything for the meantime. We have to leave it at this stage, and we do the same for the given other determinant here. We have to do the same. So we have to apply the same concept again, guys. So this is x, y, 1, 3, 2, 1, -6, -4, and that's a positive 1 like this, which is equal to 0. So we have to apply the same concept of the determinant. Remember, we used plus, minus, and a plus. So we are going to focus with this row. That is why I have taken this sign, plus, minus, and plus. So it's going to be plus here, minus, and a plus. So it's plus x. So which means it's just going to be x like this. You find the determinant. That is when you close the row and column where there is x. This row and this column where there is x. So you're going to be left with this 2, -4, 1, and 1. You do the same for minus times y there, which is minus y like this. You close the row and the column, this one. So you're going to be left with 3, 1, -6, and minus and positive 1. That's plus times 1, which is plus 1 like this. You do the same, find the determinant according to 1. You close the row and the column. So you're going to be left with this part here, which is 3, 2, -6, -4, which is equal to the determinant of 0 like that. So remember the concept, guys. We have to find the determinant. This means determinant of, so it's going to be 2 and 1 there. That's 2 times 1, which is 2 minus 1 times -4. So this is 1 times -4, which is -4 like this. So 2 minus -4 is going to give us 6. So this would be positive 6 times x, which is 6x. That's the same again here. This is your major diagonal where there is 3 and 1. So it's 3 times 1, which is 3, minus 1 times minus 6, which is minus 6 like this. So that's going to give us 9. But here there's a minus which is there. So it's 9 times minus y, which is minus 9y like this. All right. We do the same here. This is our major diagonal, which is 3 and minus 4. So 3 times minus 4, that's minus 12, minus 2 times minus 6, which is minus 12 like this. All right, this, okay, let me just try just this side. So this is gonna give us minus 12. So that's minus 12 plus 12, which is a 0 there. All right. So from this case, you will see that this is 0 times 1. Any number times 0, that's a 0. So which means here, there's nothing that you're going to get because this is a 0 here. So you're just going to equate to the 0 there. So as you can see, we are now having another equation in terms of x and y. So we can reduce just like the previous part. I can choose to reduce this one by 3, by 3, by 3. So if you reduce this, you're going to have 2x minus 9 times 3, which is 3y, which is equal to 0 like that. So we can say we are now having the second equation. We are now having the second equation there. Remember what we had. This is what we had from the first equation. We already made x to be the subject here. So we can substitute equation 1 into equation 2 since x is the subject. So we can substitute equation 1, that is, into equation 2. All right, so let's see what you're going to have there. If we substitute equation 1, this one, into equation 2, so in place of x, I'm going to put, or I'm going to substitute this 4y plus 5 in place of x here, in place of x. So it's going to be 2 into x, which is 4y plus 5. So you substitute that value of x, which is 4y plus 5. But remember, there is minus 3y. So you have to write as it is because you are substituting where there is x, and this is equal to 0. So in fact, solving equations, there are so many ways of solving equations, guys. So many ways to solve equations. Okay, so let's just expand here. 2 times, that's 8. 2 times 5 minus 3y is equal to 0. Take note, 3 is not part of the bracket, so you expand with 2 minus 3y is separate. Then you can collect like terms. That's 8 minus 3, which is 5y plus 10 is equal to 0. So you can transpose, as you can see, 5y will be equal to negative 10 because it was a positive here. So if I divide by 5, I'm going to obtain negative 2. That will be the value of y there, which is negative 2. But remember, I want to find the value of x and the value of y. So for x, I'm just going to take this advantage here, where we have already made x to be the subject. So which means x is equal to 4y plus 5. That's what we have here, 4y plus 5. But the value of y is there, it's negative 2. So x is going to be 4 into negative 2 plus 5. So therefore our x is that's going to be negative 8 plus 5, which is negative 3. So x is going to be negative 3 there. So therefore x is equal to negative 3 and y is equal to negative 2. So that is the value of x and the value of y from the given determinants. So as you can see, determinants can be used again to formulate simultaneous equations. So that is how they can test these questions. Actually, you have to be very, very careful with the type of question that you're given there. All right, let's see on 5.2 where we are to solve that equation. All right, let's just write this equation down so that we see what we're supposed to do there. That's the square root of 2 to the exponent of x, that's x not 2x, then plus the square root of 2 to the exponent of x plus 2, which is equal to 24, like this. All right, so we are asked to solve for x, that equation there. So always you ask like yourself the type of equation that you are given. These are exponents here. So remember, from your exponents, square root simply means to the exponent of a half. So if there is x like this, is going to be 2 to the exponent of a half x, because there is already an exponent there. Plus, we do the same here, square root to the exponent of a half. So this is going to be 2 to the exponent of a half, like this, but there is an exponent of x plus 2 that is there. So you can just open a bracket for that one, which is equivalent to 24. This one, let's just rewrite as it is. This we'll see later on. Then if you are to cross check here, there is an exponent and an exponent, so you can actually expand brackets, which is 2 to the exponent of half x plus half times x, which is 2 to the exponent of half x plus half times 2, which is going to give us a 1 there, and this is equal to 24. Then we know that from our factorization, here there is something that is common that we can actually factor out here. So we can actually factor out this. Remember, why are we saying so? Because this part here can be written as 2 to the exponent of half x plus 2 to the exponent of half x by 2 to the exponent of 1. Remember that when you are adding exponents like this, it means you were multiplying the bases which were the same. So 2 and 2 are the same, and these are the exponents that we're adding, which is half x and 1. All right, so that means you can factor out now, because this is the same here. As you can see, this part here is the same. So what are we going to remain with if we factor out 2 to the exponent of half x like this? Remember, to factor out, you have to divide this term and this term. So as you can see, they are the same. So you're going to be left with 1 plus this term and this term cancels. So you're going to be left with this 2 to the exponent of 1, which is the same as what? As 2, which is equal to 24, like this. All right. So as we can see, these two numbers can now add each other, or you can just divide by the bracket of 1 plus 2, divide by the bracket of 1 plus 2, of which you know that 1 plus 2 is what? Is 3. So this can cancel because it's multiplying, so it can cancel each other like this. So that means you are going to be left with 2 to the exponent of half x. From this part here, you're going to be left with this. Then what is 24 divided by 2 plus 3, or what is 24 divided by 1 plus 2, which is 3? We are going to obtain 8 there. So this is going to give us 8. So we are going to have 8 like this. So as you can see now, we are at a stage which we are used to, most of us, this stage we are used to, where we can write these numbers in the same base. So 8 can be written in base of 2, which is 2 to the exponent of 3. So this is going to give us 2 to the exponent of half x, which is equal to 2 to the exponent of 3. So the bases are the same, so it means the exponents are the same. Half x is equal to 3. So what is the value of x? Cross multiply, or you can just multiply by 2 both sides like this. So this is gonna cancel. It's 1 times 1x, which is x is equal to 6. So that is what we have, guys. So as you can see, some of these questions actually they will be testing how you can relate your exponents, how you can use the laws of exponents to solve such typical equations. So you have to be familiar to these typical questions. Okay, let's see the other question that we had, which is sketch the graph of a parabola. Okay, that's a parabola there. Clearly indicate the intercepts with the axis as well as the turning points. All right, take note, guys. We need the intercepts with the axis as well as the turning points. These are the most important things. All right, so that's let's see what we have. So we are given a parabola here, so you can just write this as f of x, or you can write as y is equal to, no matter the way that you want to do it. So I'm going to write it as y is equal to minus x squared plus 6x minus 8, like this, so that we can actually normalize our function. So remember, it's a parabola there, which is a quadratic function. So for the intercepts with the axis, remember we have got the x intercepts and the y intercepts. So the x intercepts are at a condition where y is equal to 0, or f of x is equal to 0. So if this y is equal to 0, that means this whole part is equal to 0. Minus x squared plus 6x minus 8 is equal to 0, like this, because we said y is equal to 0. So what type of an equation is that I'm going to solve there? We are given a quadratic equation, so I can simply make this x to be positive. This is possible, which means I have to divide by -1 throughout, so that at least I can work with a positive term instead of a negative here. So let's just divide, guys, which is x squared minus 6x, this one and this one, that's positive 8, which is equal to 0, like that. So I can actually factorize here. Remember, the coefficient of x squared is now a positive 1. So you simply find factors of what? Factors of 8. What are these factors of 8 that you are going to add to obtain -6? So remember, factors of 8, that's -4 and -2. If you multiply these two numbers, you obtain 8. If you add these two numbers, you obtain -6. So that's -4, -2. So from this part, x is equal to 4, one bracket equal to 0, or another bracket equal to 0. So x is going to be +2. So these are the values of x at the x-intercepts. So we just have 2, 0 there, and what? And 4, 0. We shall talk about this later on. Let's just write them here. Then let's find the y-intercept. So the y-intercept is at a condition where x is equal to 0. So as you can see, when x is equal to 0 here, you're going to be left with -8. So our y-intercept is 0, -8. Y is equal to -8. All right. So we need the turning points. So for the turning points, you have got two options there to find the turning point, because it's a quadratic function, so there's one turning point there. So like I said, we have got two options to determine that one, and which are these options that we are talking about in this case. So this was a minus there, this is minus, sorry, this is minus there. All right, so which are of these options that we can have? We can use the derivatives to find the turning point, or we can actually use this condition that at turning point x is equal to -b over 2a, or we can simply use that at any turning point. So at any turning point, thus dy dx is equal to 0. If it is first derivative is equal to 0 since it's just one and the same thing. So that's divide x is equal to 0 at n turning point. So let's just quickly find our divide x here, which is going to be negative 2x, okay, plus 6. And this is going to give us a 0 because the constant. So take note, we multiply, then we subtract 1. So that's going to be negative 2x. And remember, a linear expression, you obtain a constant, which is a 6 like that. So we are saying this is equal to 0 at any turning point. So that's minus 2x plus 6 must be equal to 0 like that. So that's, we can solve for x, which is minus 2x is equal to this part, this side, which is going to give us negative 6. So let's just divide and see here what you're going to obtain. That's the value of x there at the turning point, which is a 3. So this is the value of x at the turning point, but this is not like a point because we are just given the value of x. So we need to find the value of y at that turning point, because remember, a point is given by x followed by y like that. So we have the value of x. What about the value of y? You substitute this 3 into this function. In place of x, you substitute 3, you substitute 3 there. So if you do that, you are going to obtain the value of y, which is a 1. So this is going to be 3, 1 like that. All right. So we now have the turning point. The turning point is there. The x-intercepts and the y-intercepts are there. So we have to sketch now. All right. The other thing that you are supposed to also check when you are sketching is this value of a. Remember, is supposed to be ax squared plus bx plus c like this. So if this a is a negative like this, you shall have a third shape like this. If it is a positive, then it shall be a smiley shape like that one. So this one is going to be a negative, which is a third shape, and this one a smiley shape. So that is when positive, always smile, sad, always negative. So that is the condition that we are having. So which means our shape or our parabola is going to be like this. Remember, this is just a sketch. So that's x, and that's our y there, got our 0 there. So we have got the turning points at 2 and 4. That is 2 and 4. So you can just say this is our point 2 and this is our point 4 in the x. Because remember, this is x. So just waste 1, 2, 3, 5 like that. Negative 1, 1, 2, 3 like that. All right. Then the y-intercept, which is at 0, minus 8. Okay, so let's just say that's our minus 8 here. Let's just say, because it's the y-intercept, so let's just say that's our minus 8. Then we also have the turning point, which is at 3, 1. The turning point at 3, 1, which is maybe somewhere here, 3 versus 1 like that. So you join your points like that. So you must just make sure that you've got a smooth curve like that. All right, so that is what we are having in this case. So a negative function, the one that has a negative, should always be pointing to the negative like that. Positive, it must be pointing upwards to the positive there. So that is the case. So this is our turning point, which is 3, 1. Remember, we are asked to indicate these points properly. So this point and this point and this point should be indicated, also to label the axis and also to just name the equation of the function, which is minus x squared plus 6x minus 8, just to name your function. All right, so that's what we had there. Then the question further on says, what is the domain and the range of the graph? Okay, and we've got 2 marks. Remember, the domain represents the values of x. That is the domain, the values of x, where it is limited, or where is this value limited. So in this case, our x is not limited, because as you can see, this graph is still working this side, still working also this side, so x is not limited anyhow. So that means this is going to be the range. So there's the domain there. So x is just going to be an element of all the real numbers. It's not limited, so it's an element of all the real numbers that we have. And the domain and the range is for the values of y. Range affects the values of y. This time the values of y, they are affected, but the values of x, they are not. I want you to see something here. If you are to cross check on this graph that we have, these are the values of y, and y is limited at this point of 1. It cannot exceed, because this is the maximum turning point. But y can go to any value there, because as you can see, it's still going there. So these values, they are not limited, but they are limited up to this point. So y cannot exceed this point, which is 1. So that is your range. So which means our range is y is less than or equal to 1. But this y always is an element of what? Of the real numbers. So y, it cannot exceed, y can be equal to 1, but it cannot exceed this value. Or we simply say y is going to range from minus infinity up to positive 1, like this. So y is going to be, as you can see, this is still going up to minus infinity, but as it goes up, it is not going to go anyway more than this value. It's going to be limited here, it goes back down, so it's limited there. But here it's not limited, it's going to continue up to negative infinity. So that is your range. So that's how you can answer this type of a question. Is the graph of minus x squared plus 6x minus 6 continuous or discontinuous? So like we saw that one is a continuous function, it still goes on and goes, so that is a continuous function. So as you can see, guys, that's what we had in order to obtain 20 marks on this question, which makes a total of 100 marks in this question paper. So guys, that's what we had for mathematics and for working on the question papers and revision. So guys, not to miss these classes, you can consider subscribing so that you become part of the family, Mason African Motives. And don't forget, guys, to share this platform to your friends and your colleagues also, that they can have a benefit from this information that we are having from Mason African Motives. Till we meet again.